you have 5 fingers, but nowhere in your genome is the number 5. What's interesting is in one of the oldest parts of the genome called Hox genes, there's a developmental program. And so it stores a sequence of steps that have to do with like climbing gradients and breaking symmetry. And at the end of those steps, you end up with 5 fingers. And so the reason it's done that way is most changes to the genome would be either inconsequential or fatal, but not interesting. So it's hard for a random search to discover flying from walking from swimming. The Hox genes curate a space for search where search is interesting. And this is very close to how machine learning works. Machine learning didn't improve ways to search, it improved representations of where to search. And so most engineering design, you design the thing. So if you wanted the primer, you would design the primer. And in the book, it talks about designing the primer. In central to biology is this abstraction. You don't design the thing, you design the program that produces the thing. And you do that because the design space is too large. And so you need this curated subspace of developmental programs. And again, that's right at the heart of how machine learning progresses. But one of the things, and so my lab's been doing a lot of work on the math of morphogenesis, on the designing programs that design things, the design of design. And so I'd say, one of the things the book hints at, but is really filled out since it was written, is the role of the designer not to place the atoms in the assembler, but to come up with the goals and constraints on the assembler, and then the design of the thing that designs the program that then designs the thing. And that abstraction is essential to be able to scale to this order of complexity.